right, section 2.2 is on linear equations. Okay. Every year I try to speed through this in Algebra 2, and it seems that everybody always forgets how to graph a line from Algebra 1. So I know it's been a long time since you guys had Algebra, and you had all of geometry last year. So really the big thing is knowing that you need the equation y equals mx plus b. So a linear function is a function that can be written in the form y equals mx plus b. Or you could see f of x instead of y, it doesn't matter. M and b are real numbers. M represents the slope, b represents the y-intercept. Okay, so linear functions have constant rates of change called slope. So that's your m value. The slope of a linear function is the ratio rise over run. So that's how you guys probably learned it in Algebra 1. So what that really is the change in y over the change in x. Notice those are subscripts that I'm drawing. It always drives me crazy when you guys do y squared minus y to the first power, right? Those are little numbers that are dropped below. So y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Okay, you can graph lines by using the slope and having at least one point. So if you have the slope and a point, you can graph a line. So number one, determine whether the data sets could represent a linear function. So when I say constant rates of change, constant means that it's always the same. So your change in y over change in x is always the same. All right, so how much am I going up? So if I want to go from -2 to 0, I'm adding 2. If I want to go from 0 to 2, I'm adding 2. If I want to go to from 2 to 4, I'm adding 2. Okay. I want to make sure my y values are changing by the same rate. So my y value, I'm subtracting 1, subtracting 1, subtracting 1. So that means your slope, the change in y over change in x, was -1 over 2. So yes, linear. So linear means it makes a line. Okay, if you didn't know that, you could graph out those points and you would see that it makes a nice straight line. Okay, now this next one, my x values are all changing by the same rate. I'm adding 1, adding 1, adding 1. But what's happening to my y values? 2, 4, 8, 16. Yeah, you're multiplying by 2 each time. So you were adding 2, and then you were adding 4, and then you were adding 8. You always have to add certain amounts. Change in y over change in x is always how much it's changing, so it's how much you're adding or how much you're subtracting each time. Okay, this doesn't have a constant slope because this first slope would be change in y over change in x, 2 over 1. The next slope would be 4 over 1. The next slope would be 8 over 1. So no, it's not linear. Okay, number 2 says state whether each function is a linear function, explain. So we're seeing if it's always in that form y equals mx plus b. So A, I have g of x equals 2x minus 5. Is that a linear function? Yes. So in this case, m is 2, my b is -5. How about b? So p of x equals x cubed plus 2. It looks like maybe you could say m is 1 and b is positive 2. But what's weird about this one? You have x cubed, right? So if you have x cubed, it's not a linear function. So linear equations do not contain variables with exponents other than 1. So you can't have exponents other than 1. So this is no. You have an exponent of 3. And C, is that a line? So t of x equals 4 plus 7x. So let's see, Sarah, do you think that's a line? Yeah, it is. So in this one, your m is 7 and your b is 4, because that's the same as if you had written it as y equals 7x plus 4. So same thing. So they can be rewritten, they can be in the wrong order. You can move them around. So we're going to use something called the intercept method when we're learning how to graph lines first. So the y-intercept is the y-coordinate of a point where the line crosses the y-axis. Okay, so don't draw this, but think of it. Here's your y-axis. Your y-intercept, let's say that was at a height of 5, it would be 0, 5. If I had one below it, it'd be like 0, 1. Notice how you go over 0 and up a certain amount. So any y-intercept is going to have 0 for the x value. So it says the y-coordinate of a point where the line crosses the y-axis, the x value will always be 0. X-intercept intersects the x-axis, and that means the y value. So the height is always 0 in that case. So the y value will be 0. So it says sometimes it's easiest to graph a line using intercepts. This is usually when the equation is in standard form or general form, which looks like a times x plus b times y equals c. So a, b, and c are all going to be integers, and a is always non-negative, so you can't have a negative for a. So we can talk more about that in a second. Okay, so here's the method you do. So you say, okay, I want to find the x-intercept. So when I'm finding the x-intercept, I'm going to plug in 0 for the y. A lot of people think 0 for x, but 0 for the y value. So in my equation, I had 4 times x plus 3 times, instead of y, I'm going to put 0, equals negative 12. So 4x equals negative 12. So x equals negative 3. Okay, that is a point. We have negative 3 for x when y is 0. So that's the point negative 3, 0. So it's right there. Okay, now we repeat the process, but now we're finding the y-intercept. So for this one, I'm going to plug in 0 for x. So I'm going to have 4 times 0 plus 3 times y equals negative 12. So 3y equals negative 12. So y is negative 4. That is also a point. Notice you don't have the point negative 3, negative 4. That's the biggest error people will make. They'll get the x, they'll get the y, they'll put them together into one point. And then they'll say, wait, I don't know how to draw a line with just one point. Okay, these are two separate points. So I plugged in 0 for x, and I got negative 4 for y. So 0, negative 4, 1, 2, 3, 4. Once you have your two lines, draw, or two points, draw your line. It's like right there. So that's your graph. Okay, you guys try it for number 2. So find the x-intercept and the y-intercept of number 2. All right, so it looked like most of you guys have the same thing. So x-intercept, here's why people really like this method, because you can do a lot of it in your head. So x-intercept, remember you're plugging in 0 for y. Okay, so I'm going to walk up to the screen. So if I'm plugging in 0 for y, here's what I do. Plugging in 0 for y, cover it up. So I get x equals 8. Do you guys see it? I'm plugging in, so that means I have the point x equals 8, 0 for y, so 8, 0. All right, if I'm finding my y-intercept, plug in 0 for x, so the x. I have 2y equals 8. So y is 4. So that means I have 0, 4, the other point. So see how you can do a lot of it in your head. You don't have to write all those steps every single time. So it's kind of nice. So the first one, we had x-intercept. We plugged in 0 for the y. So we covered it up. So we got x equals 8. So that was the point 8, 0. For the next one, we found the y-intercept. So we covered up the x. So I got 2y equals 8. So y is 4. So that's the point 0, 4. So I have 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. Didn't give you much room, did I? 1, 2, 3, 4. So something like that. And that's your line in the end. High fives. All right, number 3. Write the equation negative 2/3 x equals 2y minus 1 in the standard form. So this probably won't be like a typical test question, but it's good to see how to get these in the standard form if you wanted to use that method. All right, so the first thing is I want everything to be integers. So right now I don't have integers, I have fractions. So I need to clear fractions. So remember how we did that? We just take our whole equation and we're going to multiply by the common denominator, which in this case would be 3. So if I had 3 times negative 2/3, the 3's would cancel. So we're doing this in our head. So 3's cancel. So I'm left with negative 2. So I have negative 2x equals 3 times 2y, so 6y. And then 3 times negative 1, so minus 3. Okay, your next step is you need for a to be non-negative, and you need x and y to be on the same side. So let's subtract our 6y over. So I have negative 2x minus 6y equals negative 3. But like I was saying, a needs to be non-negative. Are you guys like, why do they call it non-negative and not say positive? Are you guys wondering that? So when they say non-negative, it can't be negative, but it could be positive or 0. So positive or 0. All right, so how can I get my negative 2? So the thing that's in front of x. How do I get that to be non-negative? What can I do? Yeah, you can multiply by negative 1. Or divide, right? So when I do that, I get positive 2x plus 6y equals positive 3. And that's in standard form. Oh, that's the end of 2.2, isn't it? Not too bad.